What's going on everyone, you're back with your boy Jono for another quick math lesson. Today we're going to have a look at displacement again, and we're asking the same question. Whereabouts am I compared to where I started? The big change in this lesson is that instead of looking at one direction, east and west, north and south, we're going to be looking at perpendicular directions. So this means that the distance that we've changed from our starting spot is going to be different every single time. And we need to give an angle or a direction to that position. The way that I think about these questions is that you followed a treasure map somewhere, right? And now you've found what you wanted and you just want to take the quickest route home. Someone's going to come and pick you up. In order for you to give them proper directions, you need to tell them how far you are from your starting point, and you've got to tell them what direction to go. You can't just say, follow my exact path. We want it to be a little bit faster than that. So for these ones, we need to give a distance every single time and a direction on our compass between 0 and 360 degrees to give the most accurate information that we can. So if we had a look at a question like this, we've gone 9 kilometers north and then 12 kilometers east. Where am I compared to where I started? The best thing about these is because we are using perpendicular directions, north, east, south, and west, when these two things come together, a right angle triangle is always formed. So I'm trying to find out the distance from where I started to where I finished, and it's just a right angle triangle. So because we're dealing with a right angle triangle, we're talking about trigonometry and Pythagoras, two of our staples in mathematics. So the trig part of it's going to tell us the direction. That angle is going to help us give explicit directions using an angle between 0 and 360 degrees. And Pythagoras is just going to tell us the exact distance that they need to go. Because we've got the two short sides, we just need to find that hypotenuse. So in order to find the hypotenuse for this triangle, we just need to find the square root of the two other sides squared. So this would just be the square root of 9 squared plus the square root of 12 squared, which is equal to 15. So the distance from where I started to where I finished is just 15 kilometers. If you do need a refresher of how we find this information using some mathematics, I do have a video on Pythagoras' theorem, but just having this understanding, square root, two short sides squared, will be enough for you to smash this topic. And now I've just got to find the size of the angle. Because I've got opposite, adjacent, and hypotenuse, I could use either tan, cosine, or sine in order to find out this answer. One little pro tip that I use is that I always try to use the whole numbers that have been given to me at the start of the question. Even though for this one the hypotenuse was exactly 15, it's not always going to be a whole number. And for this reason, it's going to be more accurate to use what the question gives us at the very start. Because of this, I've got the opposite and adjacent sides, so I'm definitely going to use tan. To find the angle, all I've got to do is tan minus 1, opposite over adjacent, which is 12 over 9. Throw this into your calculator and you get the answer of 53 degrees. So now I've got my distance and direction, I can tell someone exactly what my displacement is. I've gone exactly 15 kilometers at an angle of 53 degrees, or 0.53 in true bearings. The other way that you could write it is north 53 degrees east, and either one of these would be accepted. So now I've got how far, my 15 degrees, and I've got my angle, my direction. I've got both components that make up displacement. So I've found my overall displacement for this question. So for this next example, I've gone 52 kilometers west and then 10 kilometers south. Again, I want you to draw it out to scale as close as you can. This is just going to help you kind of recognize or have a guess before you get started. Again, I want to find the distance and my angle inside this right angle triangle. The distance is just equal to the square root of 52 squared plus 10 squared. Throw that into your calculator and you get 52.95. This makes sense. I've got one long side and one really short side. So the distance was always going to be just a little bit more than my biggest side. So now I've got that, I've also got to find my angle. Again, I'm going to use tan, just so I'm using the whole numbers that have been given to me. So I've got tan minus 1, 10 over 52, and this is equal to 11 degrees. So I'm going to throw that into my triangle again, but this is not my final answer. 11 degrees is saying, hey, you're basically going north. What I do need to make sure that I'm doing is that I'm positioning this 11 degrees in the context of my whole compass bearing. So because I've gone completely west to start off, that's 270 degrees. And then what this triangle is saying is that I've gone a little bit south or back this way 11 degrees. So instead of being at 270 degrees, I've moved back that 11, so I've actually gone at 259 degrees. This is all you've got to now write. My distance was 52.95 at 259 degrees. That's my final answer. So just making sure that once you've found the angle, that's not our work done. We've got to make sure that we know what that angle is doing compared to our 0, 90, 180 and 270 markers that we definitely do know. Once you're on top of this, we just need to add on or subtract the angle that we found to give us a really clear idea of the direction that we've gone. I kind of don't think about this as actual science. Really, it's just an application of right-angled trigonometry and Pythagoras' theorem, and it does help us tell the direction and the distance that something has moved. Because we are talking about these two things, magnitude and direction, we are talking about a vector, which is why it comes into physics, but the mathematics behind it is not too difficult. You've probably done this stuff in like year 9, and if you're on top of that, really we're just answering a worded problem. If you do need help with these concepts, the trigonometry or the Pythagoras, I do have other videos linked in the description below, but I think you will be able to find these all right. Thanks so much for watching, and I'll see you later.